Welcome to a new video. In this video, we will talk about k-nearest neighbors algorithm. We will cover both KNN classifier and regressor, and we will talk about hyperparameter tuning for KNN models. We will start with models with base parameters for the regression and classification side, and then we will see about the parameters, which will optimize the model's performance. I will use make classification and make regression methods for dataset creation, and we are going to see the concepts from that datasets. And let's start with classification. So at the first side, we will import the libraries we are going to use. We will use NumPy. We will use Matplotlib for visualizing our data, and I will say pyplot, actually matplotlib.pyplot as plt, and I'm going to say sklearn.datasets. We are going to import make classification, and I'm going to import train test split from model selection. And great, so let's create a dataset. We will say x and y, and we will use make classification, and let's set the number of samples in here as 100, number of features in here as 2, and let's set number of classes as 2, and let's say number of clusters per class 1 and number of redundant 0. So let me make it more visible for you like this, and we are going to create our data like this, and let's see what our x is looking like. Here it is, and let's check our y. Great, so we have two classes 0 and 1. And now what we are going to do is we are going to use train test split, which is really important for model creation, because we are going to see our model performance on unseen data by using the x test and y test. So what we will say x train and x test, y train and y test. Then we will say train test split, and we are going to do x, y, and we are going to set something like test size, which says that 20% of the data is going to be in the testing set in this example, and we can change this number. If we make it 3, it's going to be 30% on the test set, and let's just make 20% because it's the general use, and I need to fix this typo to this to work, and here we have it. Great. So what we are going to do now is we're going to visualize this data. Like, I'm not going to use train and test for visualization. I will say scatter, and I'm going to say x, and I'm going to take this, and then I will say for the other, and I'm going to say c is going to be y, and I will say cover map, let's say this, and let's set also markers, and let's set an edge colors in here like k. Great, so let's give the title like our data, and we can just say x label like feature 1, and for the y label we can say feature 2, and we can just use plt.show at the end of this, and this is our data in here. So it can be seen that we have two classes in here, and we are going to create a KNN classifier right now. So it's a binary classification problem, and we have splitted our data into training and testing sets. Now let's move on to implementing the k-nearest neighbors algorithm. Let's import it firstly. We will say from sklearn.neighbors import k-nearest neighbors classifier. Here it is. And after that, we are going to initialize this like KNN, and we are going to say k-neighbors classifier, and let's say number of neighbors 3. This 3 here means that it's going to look for the closest tree, and it's going to decide its class based on this. Like, this is the center in here for this point, and it's going to look for the 3 neighbors and their class, and it's going to decide the entry's class by that. Like, if a point in the yellow side and 2 of the neighbors of the new point is yellow and 1 is the other color, so it's going to classify that entry as yellow. Great, so we are going to just train the model right now using the fit method, and we will say xtrain and ytrain. And after that we are going to make predictions with this algorithm, like we will say knn.predict, and we will give the x-test, and here are predictions, and we are going to store them in a variable, like we are going to say predictions is going to be knn.predict x-test, so it's going to be in a variable right now. Like I can just print it out and you can see easily from there. And let's get the score of the model, like knn.score, and we will give x-test and y-test in here, and it's 0.95. Great. It gives the accuracy, and you can also get accuracy like from sklearn.matrix import accuracy score, and you can just call accuracy score. You can give y-test and predictions like this. Both works. Okay, now the parameter tuning, and let's learn about the parameters of this algorithm. We are going to say from sklearn.model selection import grid search. For the parameter tuning side, it's going to try different parameters with the grid search, and I'm going to say parameters grid classifier, and we are going to define our parameters like we have number of neighbors in here. It can take values like 3, 5, 7. You can extend these values for trying more things on the modeling side, and we are going to set the weights, and it can take like uniform distance, and we have a p parameter, like we can set it as 1 and 2. Also you can extend this one, and now we are going to create the knn classifier, like knn classifier, let's say k neighbors classifier in here. And now we are going to initialize this grid search, like grid search classifier, and it's going to be grid search cross validation knn classifier and parameter grid and classifier, and let's set cross validation as 3. So what this is going to do is it's going to loop through these parameters and going to find the best ones in terms of performance. When we fit this, like grid search classifier that fit, and we are going to use training data like this, xtrain, ytrain, and here it is. And you can get the best parameters, like you can say grid search classifier, and you can say best parameters after that for seeing the best performing one. Number of neighbors is 5, p1, and weights is uniform. So you can extend these values for getting better performance on the models. If we say 7, it's probably going to be better, and you can try different parameters and you can just find out the best parameters, and it's great. So let's get the score from this grid search classifier best score, and also we need underscore after that, and here it is. So it's 0.98 this time. We improved the performance because it was 0.95 and it's 0.98 right now. So let's also look for the regression side. We are going to import make regression this time. We'll say sklearn.datasets import make regression, and after that we are going to do x and y, and we are going to say make regression number of samples 100, number of features, let's say 1, and let's add a noise in here like 10, and let's see the x and y. Great. So I'm going to say xtrain, ytrain, xtrain, xtest, ytrain, and ytest, and I'm going to say train test split, x, y, test size is going to be 0.2, and let's run this, and also let's visualize this like plt.scatter, and we are going to say x, y, color, let's set the blue this time, markers, we are going to add markers again like O, and edge colors, and let's set it as K again, and we'll say title regression problem, and let's give it X like feature and label like target, and we will use plt.show at the end of this. Great, so we can see that we have a regression problem in here. So for the first step, we are going to use base model. So I'm going to say from sklearn.neighbors import kneighbors regressor, and then I'm going to do knn regressor is going to be k neighbors regressor, and let's set the number of neighbors as 3 again, and let's make predictions. After fitting this model, we will say knn regressor, and we will use .fit, and we are going to say xtrain and ytrain. Then we are going to do like knn regressor. After that, we will say predict, and we will give the x-test for it to predict. And let's store these predictions in something like predictions. And after that, we are going to say, let's get the mean squared error. So we will say numpy.mean, and after that, we are going to say predictions minus y-test in the power of 2, like this. Great. Also, one other way for getting the mean squared error, like you can just say from sklearn.metrics import mean squared error, and after that you can just call that, and you can give y-test and predictions inside of this, and you will get the same result. It's both same, you can just pick the one you want. And let's do parameter tuning. So we are going to define a dictionary like parameter grid regressor, and we are going to say number of neighbors. We can give it values like 3, 5, 10, and weights like uniform, and distance, and let's say p, and we can give like 1, 5, 10, and here it is. So there's a typo in here. I'm just going to change that like this, and it's going to work right now. And then what I'm going to do is I'm just going to initialize the model like knn regressor, and I'm going to say k neighbors regressor. Then I'm going to initialize the grid search like grid search regressor, and I will say grid search cross validation knn regressor parameter grid regressor, lowercase letters, and after that let's set the cross validation as 3, and we are going to just use fit method with this like xtrain and ytrain. And after that, actually we got an error, cannot clone object. I'm missing something. Yeah, here it is. So I will just add parentheses after that, and this time it's going to work smoothly. Yeah, great. So let's also get the best score like grid search and regressor.best score, and it's 0.97. Great. So that was all for the KNN video. Thanks for watching it. I'm creating content about data science and programming, and you can subscribe to my channel for more. I have playlists for machine learning videos on my channel. You can easily reach to that from my channel playlist page. Have a great day.